had a little chat before. Because now I'm thinking what to do when you come. You know, because my Professor Cole, who's my Fraunhofer colleague, he's TU and Fraunhofer.
Hello.
I'll talk about it.
Good afternoon, everyone. I would like to welcome to today's topic lecture, which is part of our 90th anniversary of the Faculty of Architecture, Raoul University. So today's sessions will be both on-site and in the Zoom meetings. Sorry. To start the session, I would like to welcome our Dean Professor Saraju Samsung for a short opening speech for us. Thank you. Please welcome Professor Saraju.
Good afternoon, everyone. It's good afternoon. Because the weather outside is not so bad. I just learned that in Bangkok, the temperature is cooler than Italy at the moment, so you should enjoy that now. So this is a good day. So we have this is our second lecture in the series of the 90th anniversary of our school. Yes. Okay. Now, in the themes of we are going for architecture and design for future societies. For future societies, it's very important that now we are moved to the more sustainable living environments. And one thing that coming. Should I do anything wrong? No? Right? Okay. So to go to a more sustainable future, so I think wood come to our mind of constructing our urbanizations. I think wood is very important now because wood is one of materials that are very fully sustainable. We learned that the concrete and steel not sustainable anymore because we have to destroy a lot of resources in our environment to have that materials. Wood instead we can replant and can reforest to have more wood without destroying things. So it's a good time that we can learn more about wood constructions. So now today we have Professor Raoul Bunschoten, if I'm right?
Yes.
From TU to guide us to know about the construction of wood, the wood joint for the new construction technologies, and also to have you in the workshop to do that together during next week. So I think this is a good time, and I think we can learn a lot from this workshop and this lecture. So please welcome Professor Raoul for the lecture. Thank you.
Before I continue, I would like to ensure that your mobile phone is on a silent mode, and we will have the Q&A session afterwards. So if you have a question, please keep it in mind and then raise your hand when it's end. And for the people who join us in the Zoom meeting, you can write the question on the chat, and then we will read it out and ask the question at the end of this lecture. And I also want to thank you, Professor Samsung, for your inspiring words. And I would like to introduce Professor Bunschoten a bit so you know about what he did in life. So Professor Emeritus Raoul Bunschoten, he is a renowned expert in the field of architecture and urban planning. He joined TU Berlin in 2011, and he is a professor for sustainable urban planning and urban design and the head of Cora Conscious City Share from 2011 to 2022. He has taught at the Architectural Association School of Architecture and London Metropolitan University in London, the Ballard Institute of Architecture in the Netherlands, and also Columbia University in the USA. And moreover, he founded the Conscious City Lab for Intelligent Urbanism in 2017 with Professor Cole of TU Berlin and Fraunhofer in Heka. And he is the co-leading of Bauhutte 4.0 project, a wood-to-city innovation and production center. He is leading research on planetary urbanism in the context of climate change, conscious city planning, and also bio-based urban production system. So I would like to welcome Professor Bunschoten to your lecture about second skin living with nature.
Great, thank you. You make a picture of me that I sent on to the rest of this title page. So, this is working? It's off? Ah, okay, great, thank you. Yeah, thank you for this nice words. So thank you, Dean Sapsuk. Is that correct? Yes, thank you. And Lasita Amat Yakul, who's my PhD student, doing terrific work. So I don't have to say anything more as an introduction. I'm just interested for a moment, what kind of level are you? What kind of audience am I facing? You're MA, PhD, BA, what kind of levels do you represent? That's roughly. Give me an idea. Yeah. And some staff? Okay, yeah, thank you, great. Wonderful, I'm very honored to be here, also to see one of my ex-students, Liz Flannery. It's always a joy to meet people again when I travel, which is just starting again, right? This is my first trip to Southeast Asia since COVID, so I'm very pleased to be back here. Like the Dean already said, it's nice and cool here after the heat wave in Europe. I'm going to take you through a series of concepts, and they start with the second skin, and then kind of move into this theme of building by nature. Second skin is something I've been working on since Chris knows me, and even earlier. It has to do with the concept of the skin of the earth, right? The earth as we know it as our home, but the second skin is the way we are making it now as humanity. And this is an infographic that we've been developing in the TU Berlin with students. And in this kind of infographic, we have many of these, right? We show the 3D print effects of climate change on the sphere as a model. So here you see certain environmental effects printed on a picture of the Earth. You can probably see here Asia, that's Europe. It's hard to see. So here you see, in fact, already the first and the second skin coming together. What we are trying to do is, in a way, these effects that we show here, to turn, these are the urbanization effects of humanity, to turn them into biogenic components. So basically create a pact with nature and not only destroy nature and ourselves, of course. We are part of nature. So since I'm emeritus, I don't teach anymore, and I'm so pleased that students, next students, of course, are teaching, like Asita here will run a workshop, and I'm leading the Cora Conscious City, and I founded an institute called the Bauhütte. It's a German word for building lodge 4.0, and that refers to industry. So it's an institution supporting biogenic construction in general. Yeah, so that's what I'm doing right now. We're creating this institute. I'm the president of it, and I hope to work with that. So let's dive in. I will talk about two main components. I have two components of the lecture. One is the skin, and the other one is the building with nature. And I'll talk a bit about the skin first. So the skin itself, and back to the theme of the skin of the earth. We just talked, Chris and me just talked about it. That was a theme already 20 years ago when he was at the AA. And the first skin, I will just say a few words about that. I'm trained as an architect in Switzerland and became more of a kind of urbanist later. So we're all amateurs in talking about kind of nature, yet we have to know something about it. So I did in this early years, this is probably even before Chris came to the AA, I was involved in a lot of kind of modeling myself. Not 3D, that wasn't existing yet, but handmade models of the Earth. This is me actually, longer hair as usual, and trying to create models of the Earth, and then we try to start asking the question, you know, what is the skin made of here? Is it an original primordial skin, or is it a skin that we are building, like this model here? And so we were creating these models like this in the Architectural Association and the School of Architecture. And on Thursday, this Thursday, I'm leading an Architectural Association Global Forum. It's an alumni forum in Bandung, in Indonesia. So I go there, then I come back here. And so here we were building the skin of the Earth, literally, right out of paper. And then we cast into a very architectural project, but it's a modeling project. So, but then the questions came later, what actually is the skin of the Earth? And the skin of the Earth, of course, scientifically, we know a lot about that. So here you see some of the earlier drawings in which we are trying to understand what that skin is made of, right? It's of course fish and plants and humans, but then bit by bit, I mean, you go deeper, it gets into rocks, and then it gets into molten lava, it becomes liquid. But and then you have volcanoes where the liquid comes out. So today, of course, one of the big issues are what is this first skin, and do we still have parts of the first skin? Yes, we do. This looks very abstract, like a painting, right? But it's actually an image that we have generated from satellite data. I'll show that a bit later, from satellite data, and it's looking at the heart of the island of Borneo, or Kalimantan, if you say it in Indonesia. And the green is still more or less original nature. It looks a bit like this, as you know it also well. And but of course, there are other forms of nature that we are exploring more and more, such as the root structures of the trees, which create a kind of intelligence. And these are the root structures of fungi that link these global forests together. And bit by bit, we're beginning to understand the kind of intelligence that are formed by these roots that are like neurological connections, like in the brain. So we're beginning to understand this is a real intelligence, and we have to understand better what is this real intelligence. If not, we don't survive. This is a still of the mycelium network from fantastic fungi, and which we're now also beginning to see as a building material. I'm just showing these images to get a bit of a sense of this first skin, and what I mean with that, and how much of that is still there. Right? We're talking about the Anthropocene now, which is the lasting influence of humanity on geology, but we're also more and more understanding that we are kind of changing nature to a very deep extent. And so that's changing of this nature is caused by humanity spreading, building cities, and creating effectively a second skin. So back to that model I made in the Architectural Association, I created a series of kind of squares, the black squares, of these models, these spheres I made for a project in the Netherlands. This is really old work. It's for me very interesting, and I show this right now because we're working on a series of books, about 6 first, but about 12 to 15 in total. You will see them coming. And so we're looking at some really old work in terms of what is the relevance of it in contemporary society. So what I was looking at these handmade models was how can you kind of sort out its dynamics. Part of the dynamics are, of course, this original skin, the first skin. But what I was interested in is kind of urban society. How do we kind of see the footprint of humans within this skin? So I started to make these kind of drawings out of these photographs done by my wife, Hélène Binet, who's an architectural photographer. So we started to look at these fragments and give them names of urbanity, but those fragments are both new cities, but they are also, I didn't tell you before, these things, right? These are traces of humanity. What is this? Is burned forest. Burned forest in Indonesia, right? And I'm showing only the better part of the map. You'll see the worst part in a second. These are also traces of humanity. And what is of course interesting is like my drawing, if I go back for a moment, right? If you look at this, which was made without really any knowledge of these forestries, right? This is just like a game drawing. Yeah. These things themselves have patterns. These are human patterns, but you don't see here the roadways, but these are the burning patterns. So, of course, what concerns us in general is these things, you know, where we are looking at the heart of the rainforest in Indonesia, and these are human patterns cutting through biodiversity, effectively separating biodiverse territory. And that's a bit what I wanted to show is this gamification. Right here you see a bit better, but sorry for the bad quality of slide. I just edited it last night. The original rainforest, and these are then the kind of the burned parts, which are then turned into whatever kind of the cows, and mostly palm oil really. So that's the kind of today's reality we live in. So that's a way what I meant with these kind of things. Although at this time we weren't thinking of the rainforest so much, we were thinking of cities, and we were thinking of a kind of game technology to create layers of the city, to understand the dynamics of a city better. And this kind of gaming is one aspect of the workshop next week. There's a bit of gaming taking place in Sita Mattia Kool's workshop. So, well, back again. That should be here, not here. So, Berlin, where I just flew in from yesterday, looks a bit like that if you're far away, right? It looks very green. In fact, 1/3 of the landscape of Germany is covered by forest. 1/3. So that's why the big drive is now towards using the wood of these forests in a better way. I'm saying very carefully, because it's actually a pact with the people managing these forests. And that don't say using, they say we have to replace part of it, because part of it is really not so good, not so rotten. And we'd like to have a higher degree of substitution. And so they were going to tell us there is too much wood. We would like it to be used in a city. We would be proud of that. That's the message we get from the forest owners. So here it looks like very green, but of course the reality, as you know, here in Bangkok is if you zoom in, it's stone, and here very much concrete also, right? So concrete, some wood inside all the buildings, steel and other materials. So this is of course what urbanization ultimately looks like. And the consequences of a lot of this urbanization is the kind of weather changes we're now talking about, this climate change and the climate crisis. So this is the house I live in. I just left here yesterday, but this is typical stone Berlin, and some renovation on the top here, there, and inside is wood actually. So historically we are quite used to building with wood. Right? This is completely wood inside. So, but this is urbanization that also constantly changes. And this kind of changing character is the thing that we now need to work with and understand better. And we have to be part of making more changes. This is a bit my mission. Speed up the changes of urbanization. And not stopping it. There's a debate in Germany, should we stop building? No more building, some people say. You have to stop any form of building. Yeah, tell that to people in Southeast Asia or in other places of the world, right? So we have to deal with the dynamics of the second skin, which you could say is really something like this. You could say this is climate change, but it's also, I say it's also data. Right? When you go to the internet, like now, we're streaming to some students that are online watching this event. We're in that set of lines, right? And in global data sets that create their own form of architecture. And sometimes we studied a bit of this architecture. These are studies we did with some students in London at some point that were looking, for example, just one example, right? This was a student of mine that asked some friends of his to have a dinner. And these friends, 7 friends, they lived in 7 different places in the world. And he asked them to note the origin of the ingredients of what they were eating, and then to map these on the world. And that led to this map. So all of those lines are food transports, right? And one point where they come together has these spider points, you see them better here, are the dinner, the place of dinner itself. So that's the world we live in now, the world of global logistics. And so it is with cities, where we have meals that come from the whole world, materials flow across the world, right? 90% of the wood that is harvested in the state of Brandenburg, which is the province in which Berlin sits, goes to China, right, in containers. So some also to Canada. So we're asking why. They say, well, there's not enough market in Germany. Build more wood, then we supply you more. This debate now I'm getting involved in. To kind of go back a little bit off from this kind of global madness, which is, you can see mapped here, you see some of the ingredients of those meals. But you can do that with any kind of product, clothing, housing, and things like that, right? So this is the second skin we're creating, and it leads to consequences. For example, here, just one example again, an example of where we get energy, right? Here is an extraction of, again, student work, right? The extraction of natural gas and compressed CO2 in the Arctic Ocean on the edge of Siberia, and here you have an extraction point, and the extraction point leads to a new city because the ice is melting, and a whole new set of cities are emerging in the Arctic, and they have their own data. Now, what you see here is the effects on the Arctic and the places where it's caused. This is, again, work done by students, right? So the Arctic is on the top, and these are measurements, data of things influencing mostly CO2 emissions, influencing the melting of the Arctic, because the Arctic is heating up 6 times faster than any other place on Earth. So that's the kind of reality that we're living in. It speeds up even quicker than you think. And so even if you're not close to the Arctic, right, you're in it. You're in this game. So we look at these kinds of data to understand better this second skin. It makes also amazing images. But so of course we are looking at some of the kind of reports. For example, here the Intergovernmental Panel on Climate Change. We're trying to understand, well, what is the UN looking at? What are these thousands of experts that are working on in that? And you can find this yourself online. It's good to look at because it creates some of the, the scenarios of how we could survive possibly, right? And it shows the kind of trends that we are in now, that we're at the moment not managing to change. And it basically sets out what we have to do to get this trend downward, right? This point we already have passed. You probably know that we have now kind of reached occasionally the level of 1.5 increase, right, since the 90s. So this one is basically over already. We only have this now, right? This. So the question is, what can we do to bend these curves? And since all of you are like me and us in the same game, it's architecture and urbanization which is responsible for 40% of global CO2 emissions and other forms of changes. We are responsible. We are heavily responsible. So we are part of this. Right, and so the IPCC is looking at these global model pathways that limit warming to 1.5, which is already passed, and the kind of effects, the kind of steps we have to take. And there's a lot of debate on that, because we're saying, well, we have all these SDGs, right, the Global Sustainable Development Goals, and then there's a debate, yeah, but they are not directly so effective, so we have these charts where what we have to do inside these simple kind of categories of the SDGs to handle these changes, like the risk of species losses, heat, humidity risk to human health. We were just discussing it. What if the temperatures reach 40 or 50 degrees? What do you do when you're outside here in the courtyard, right? Food production impact and so forth, right? All these things that are happening. So that's the kind of context we have to now act in. And therefore we get to be building with nature. It's a survival strategy, right? So we've been working actually on some machine learning. So we've been introducing AI in the curriculum for architecture. These are just some exercises students did. It's very interesting. Of course, it goes back from urbanization, like the city of Berlin, into some sort of natural state. As you can see here, we have kind of desert and then kind of forest and things like that. These are really just pedagogical exercises, because we feel AI has to be part of an architectural curriculum, right? But they're also interesting because they kind of become wishful thinking. In fact, what's happened is the opposite, right? We've come from the end of this exercise towards this the urbanization of the skin. But I believe that AI is a kind of inescapable part of the future of design, simply because of the complexity. So I'm showing you a few examples. Right? This is an artist that is beginning to work using AI, but using nature itself, like bees and so on, in order to create gardens. Now, she's an artist, so she's mainly concerned in the creation of gardens with using bees to make the pollination of the. And it's something you can find online. You can actually create your own garden, setting a series of algorithms that then are used to place seeds in this garden, and the rest is done by bees and other insects. So it's a beautiful project. It's now created. There's one example of this in Berlin at the Museum of Nature. But when I saw this, I was really inspired. I thought we got to think of this also in terms of urbanization and kind of link to nature. Like in forestry, we're going to have to use this way to fill in these gaps that have been created now in forest, to deal with the dead spots in the oceans and things like that. So it's just one example of kind of linking of the latest technologies we have with nature. And urban to rural landscape and actor gradients, right? This was a project of some students of mine where we've started to link urbanization to natural processes. Again, in gamification, we do a lot of gamification because gamification leads to negotiation. And since there's so many conflicts, we need to negotiate. I had a colleague in Indonesia just texting me before this lecture. She was just in a meeting in Sumatra with farmer organizations for palm oil farmers, the kind of big companies like Unilever selling the stuff, local NGOs trying to protect the forest. And she said it's so tense, so much conflict. And so we have to learn forms of gamification to negotiate this process. We also have to learn the complete value chain. This is a static image you can download from the internet. That is a diagram of a value chain. Value chain means inbound logistics, operations, outbound logistics, marketing, sales, service. And then you have a firm infrastructure, human resources, technology, and procurement. This stuff we usually don't really look at because it's industry. Right? Some people even frown on it. But we've been working on it, and this is a diagram made by Sita here, where we are looking at the bamboo to city value chain. This is a new thing we're trying to work on. We were trying to work on biogenic materials, wood very much in Europe, but increasingly we're looking at Africa and also in Asia at the possibility of using bamboo as a kind of smart material, the future material. And I'm not talking about the so-called traditional bamboo architecture. We're talking about engineered products, right? This is something you'll see in the workshop. I think Wasita already has kind of ordered some engineered bamboo components. They're here in the building. So here, this is our own firm of value chain where we look at the raw material supply from the forest, manufacturing processes, the building assembly itself, the building maintenance, renovation, disassembly, and then waste processing, disposal, recycling. Right? It doesn't stop it at the building; it goes on. Right? In Germany, you have now proof that all the materials in the building can be recycled. So this is what we feel is a kind of core part of architecture and construction now. And so we're looking now at how to apply that to what we can do as architects. And so I'm going to go now through these steps. I'll take you through these colors right now to show you a little bit the kind of work we're going on. And again, linked to this image here, we've created also several tools. And there are tools about, first of all, observing what is where the raw materials, and second of all, how they flow. Like if you build a building of concrete, the sand increasingly comes from Saudi Arabia, for example, because sand is becoming rare in Europe, for example, maybe here too. Right? And other products come from somewhere else. The lithium in your telephones comes from South America, right, or Africa, and so on. So where does the stuff? So here we've been looking at Indonesia. These are some early versions of the tool. You see some tests where we've been doing. This is about availability of bamboo land in Indonesia. I'm there on Thursday, and we'll have talks with people here in Bandung and with people that work here in these areas. And here you see some of the statistics. That here you have Thailand, for example, and the potential bamboo farming in Indonesia, Thailand, Myanmar, Cambodia, and so on and so forth, right here. These are at the moment, these are satellite data that we work with. We work with open source data, but then several PhD students like Wasita are then connecting these to regional data or local government data. Or local open source data, and maybe increasingly data held by companies and landowners. And so we have to go top down and bottom up with that. And so back to this picture again. Right before I showed you this picture, a picture from this area here. Now you see the complete image, and this is the picture of the current state of the forest in the island of Borneo. Right, you have Malaysia here and Indonesia here. And all of these colors mean basically burned forest, cut forest, replaced forest, and most of it is palm oil now, but not everything. But all the colors mean it's lost forest effectively. And what I talked about before, these patterns, right, is something now with colleagues in Germany and other places I'm looking at very closely. Are these patterns here? Right, because you know these are the areas of the orang-utang, right? And I was asking some experts recently, have they met now, these corridors? Because once they meet, it's over, right? The biodiversity is going to collapse effectively. This is the area of the new capital in Indonesia, which the architect of that will be speaking on Thursday in that conference I'm leading. And we've been doing some tests in, can you actually replace some parts of this forest here? Some of this is also mining, colonial mining. And of course, the big debate is between the biosphere of the ocean and the biosphere of the forest. So if you build a capital here, you have to really ask yourself, what do you want? Do you create more urbanization, or do you begin to create some sort of restorative action between the biosphere of the ocean and the biosphere of the forest? But you can see the task is incredible. Like only last year, in 1 year, we have lost 10% of all rainforest in the world. 10% in 1 year. So just imagine, just calculate that further, right? This is what's happening right now. So, and here you see, right? It kind of changes. I just went one step further. Right? These are the palm oil areas in both countries. So here's one glimpse of the work of Vasita. You have to ask her for a lecture yourself. For her, this is the PhD work she's doing, and this is the software she's been developing herself, in which she looks at. It's an analytical project at the moment. This is in Thailand here, both physically and through the data, and she's looking at suitable areas for growing bamboo, and it's this is a result of combining several ecological and human settlements. But basically what she's looking at is creating a kind of a graphic structure, but it's a tool, right? It's an interactive tool based on open source data, with which she analyzes where is bamboo possible growing, where are the production sites, where is the need for new construction, let's say of housing. And we will be visiting some bamboo growers and some bamboo production sites here in Thailand in the next few days. And so it's highly data driven. So don't think building with nature is something that is like cute or it's like ecological, as I would say. No, it's highly technological. So you really know what's where and when. And these things are partly available, partly not. So we have to learn how to look at the data that are not available. So the transport, for example, logistics is a key point. And so emissions created through logistics themselves are part of this value chain issue. And on a quite slightly larger scale, I'm showing you a few images of kind of our studies of logistics. For example, we'll be looking at kind of global logistics and can they help our process in using raw materials from nature for urbanization. And this is a student project in Africa trying to create forest connections to shift to urbanization in Africa towards nature-based urbanization. But when you look at African cities, they are big, and we think they are big and fast-growing, but actually we're only looking at 10% of what will be built into the next 20 years. So if you calculate it in terms of emissions and other things, it's catastrophic. So what are the possibilities to build nature-based cities in Africa will be a big issue. And I have some students also working in African countries. Now, touching on logistics, of course, you see this is actually a model, an analysis of the Belt and Road Initiative. That is China. China has, since 1913, has created the world's largest logistics system in the world, and you're a part of it, right? Thailand is in it, as you can see here. So these are the kind of main line, but what really matters is what happens at the kind of facilities, the ports and so forth, everywhere. And this is of course a major factor in urbanization. We shifted then from the analysis of the Belt and Road Initiative to a more general program of supply chain urbanism. But look at, for example, what is happening in Indonesia, right here. The kind of Belt and Road, right, goes through the heart of the archipelago of Indonesia, which is creating kind of a major issue in Indonesia. How to kind of handle this, how to kind of negotiate this, and of course East Africa we know about. So these kind of global logistics are also a major part in thinking how to build with nature. So one of the things I'm working on with the Indonesian government is to work with the overall maritime strategy of Indonesia, it's called the Maritime Highway, to distribute engineered bamboo across the archipelago. That's one of the things I'm working on in the next few days in Indonesia. And so here you see some of the effects of this Belt and Road Initiative on different cities worldwide. And we're about to publish a book in a few months' time. You will see it about the Taiwan Strait. We started working on this over 20 years ago, and it's now finally coming out in a time that's completely changed. This will be a major site of conflict, possibly. I hope not. But there's a lot of stress and tension right now. And it's about negotiating logistics across the east of China, the east of mainland China, and Taiwan, which of course is again part of this Belt and Road Initiative. I just wanted to put this in. I just wanted to also show sometimes the joy of graphics, right? The joy of making these kind of maps, and the kind of beauty you just sometimes get through abstraction. And although this is still full of meaning, this is the city of Xiamen in China, and these are different icons that denote production, logistics, and so forth. So, and we have done a lot of mapping. It's a big book, and it's a beautiful book, and it will be about negotiation when it comes out. So the negotiation itself is something we've developed over the years. We are developing a conscious city game box. In this workshop, there will be one day of that gaming, and it will look a bit like that. It's very simple, but we do it a lot with, for example, here, these are students of Taiwan and mainland China. These are some images we took some years ago into the negotiation processes to create the kind of maps for this book. So this was quite a rare thing to have students coming together from Taiwan and mainland China. We had to do all kinds of stuff to make that possible. This was in Shenzhen, and this is in mainland China, this is in Taiwan. So there is a lot of theory behind this. It's not just a game, right? It's actually creating DNA structures for decision-making processes. So what this table does, and we do this with experts in Germany, it creates scenarios which are like a DNA structure in order to decide at what point a card representing a prototype can be introduced. At what point do you build a factory? What kind of factory and where is it? Or what design do you make? And so that's the kind of the theoretical background of this kind of very simple looking gaming. And here you see the theory and the kind of what we call management board, and here you see a page from that book about the Taiwan Strait that introduces some. Here you see this is the Xiamen in China, and here you see some prototypes, and it's about kind of introducing these prototypes in the city. And prototypes, for example, can be, putting two ships together to turn it into a kind of logistics place in the middle of Indonesia. Just to mention one thing, in order to get wood stored coming from one place in Indonesia, going to another place in Indonesia. And production, this is a key process. My partner in the new Bauhütte 4.0 institution is a professor and a leader of Fraunhofer. Fraunhofer is Europe's largest research institute, and it deals with production. And so production of materials. And this is again some students looking at flows of materials and production, and looking, for example, at the kind of what production can do in the gradual change of a city going from kind of mineral base to bio-based. We're once more in Indonesia, we're here, and this is a city close to the new harbor that Indonesia is creating, and it's an attempt, I have to say very carefully, it's an attempt to create a gamification planning process in order to use all the materials, 100% of the oil palm for construction. So it's accepting that oil palm exists, but can we use it for 100% and for construction? And so it leads to a concept of a city, whether you like it or not. It's a test that combines nurseries with more traditional types of housing, with effectively industry inside the city that processes the waste of the palm oil. Today, I believe, it's not good enough. We need to get rid of palm oil. We need to move on, right? We need to wean the farmers off, and going into this much more here. But this is a slow and difficult process. So in order to do that, we've been looking at the possibility of creating an exhibition of production in Berlin. This is a famous ex-airport building where we were planning an exhibition of production of wood. So this is wood component production, and some examples like prototypes and meeting places here. This has not happened, but we're now with this new institute, the Bauhütte. We're going to produce something like this in another ex-airport, and we're doing that with Fraunhofer, whose logo you see here. So we're now combining these two, TU Core with Fraunhofer. I'm very happy because they're very big. So this is a little movie that explains what we're doing right now. So this is the largest wood-based district in Europe that will use production and typical factories. Maybe the factory itself is wood-based. And here you see some examples of almost 100% wooden-based buildings. I'll show you a few more. And so this is 100%, right? And of course we're learning from historical kind of wood joints. It's not all new. It's actually partly really historical. For example, the temples here in. So there you see, it's actually a real building. Now look a bit closer, because here comes also the issue of how we use AI to create a selection process of different types of housing, plans. It's not so easy anymore to fill a city like this with many architects. And so it's a very quick glimpse of the different methods and technologies involved. And here you see the percentage is changing here, right? Because in this tool we're saying, well, what does it mean 50%? And you see the same here. Look here, down here, right? You will see the percentages changing, so that means that the components have to be designed in a different way. And that information then goes back to the actual production, like here. We're just working on this right now. So here we're filling in the Berlin. 100% staircases, for example, in wood, student housing. And of course we have to do this with locally sourced wood. So you see that. So these are the kind of partners we are talking to right now in the local and regional forest. But of course, this is a kind of global project. So now a few glimpses of the kind of types of production we're needing, and the kind of factories that are emerging now. Architects don't love these things, but somehow we have to learn to live with them and to think of massive production sites. But we are working also the possibility of flexibility. Small architects' offices, they can design something that can be like an afternoon of the production here. But if you look at hundreds of thousands, millions of housing units, like are needed in Indonesia, you need real production. And so you get things like this. I just visited this factory. It uses the state-of-the-art of production. It's called Nokira. It's not great, but we have to work with them, because we have to let the architects kind of work with them and design these things better. So, and it's like that. Like I said, the architecture is what it is. It can be better, but so now let me move into the kind of last section. I'm showing you a few glimpses of a tool here, and this tool is developed mostly by another PhD student, Sebastian Munoz, and he's from Costa Rica. And now it's quite advanced, the tool, so we're beginning to look at partners to work together. And what this tool does, it simulates the complete material flows along the value chain. So from forest to circularity and recycling. So I'll come back to that, but because that is really based on the design of things. How do we actually then design with wood that it's possible to make with regional wood, that it's possible to create multiple housing units with the variation that the citizens want, with robotic cranes, things like that, with building kits that are overseeable. This is a complete building kit for one high-rise made in wood. So these are wood panels that can be lifted by a kind of a robot or cobot, right, and can be put together, because we believe we need this technology so people can be free to be more creative. They're not simple system, although it looks simple, because you have different components, right? And you have these panels, but sometimes the construction itself is very simple. It has to be so simple that the robot can understand it. Let me say it like this. And so you come to, these are test projects done by students, master students in my studio. Right now they're not possible yet. There's still too many regulations relating to fire and production that this itself could be built. But we're not far away, and some very interesting results are coming, right? For example, here you have these kind of interiors you have kind of very nice plans that come by being inspired by some very great architects in Berlin. You get very interesting fitting kind of exercises that then will be taken over by robots. And this is pretty high already for wood building. At the moment in Germany, we are looking, to get first buildings of this height are emerging now. They're not 100% wood. They're still below 50%, but it's getting there. It's getting there. So, and of course, we have to understand how everything fits together. How do you actually make things work that it can be wood and fitted together? And it's still concrete. We call it hybrid. The floors will be. And here you see, we've been looking a lot at kind of Japanese wood architecture. So very, very traditional kind of things to create these kits, using the technology that's used at the moment in the car industry or in other types of industry like that. The machines exist, but how do you put them in sequence? And the tendency is to go towards this type of construction technology. They're hanging robots so that you have mobile islands of components. And you have this kind of factory. It's not really linear anymore, right? You have things that move around. It's kind of an intelligent process. And here, I'll just give you a glimpse of one of these things. That's again developed by students. The joints are 100% wood. And I just attended a congress in Berlin, the National Congress. Everybody's looking for this kind of thing, but it's not easy yet. Like even the dowel. See, there is no metal at the moment involved in this. There's a few examples, but not really, because it's the engineering that's still lacking. We don't yet know exactly how to calculate it, although the top engineers say, yes, we can do it. And there are already examples of this. Of course, we are not showing the cellar, which at this stage would still be concrete. So, but in principle, we're there. In principle, these things are possible. See, the apartments go in. So let me just go on to the city scale. So if we want to do this in the city, let's say all of what you see here in pink, all of what you see here in pink is wood-based. That's not happening yet, but we are trying to do it. Like if you see these things, these are existing buildings, and we're putting 2 floors on top of them in planning, right? This is the aim. This is what we want and what the city wants. But how to do that is not so clear yet, because we have to look very closely at how you can top this up, how you can extend here, how do you have new building. This is the big rage in Germany at the moment, extensions, topping up and things like that. And for that you need also city visions. That's why I used this picture on the poster, because we once did a competition which we won in Germany in that same airport, right, to create a kind of energy plus district. This was 12 years ago. Now this is urgent to create energy districts. I would say now this has to include biogenic production. But you need everything you can have. But here you see the calculation of the energy gain we would create by having new technologies in this district. And I would say the same we can do by biogenic production. We have to work with such kind of savings and generation diagrams, but also we have to create visions for cities. And visions for cities we've done in many places. This is a city in Italy in the south. For visions, you need people. You need the connection to organizations that represent people. So you need these kind of diagrams to understand who is involved really, who's there, to what extent can they be part of the vision. That's really the kind of cutting edge planning now. In order, for example, to create local agriculture. This is a prototype developed for that city, creating locally produced goods for a city. Now, the ways to do that is, like I said before, negotiation processes. Now, this is done with students. Now you see some students and the former assistant doing this in the TU. And you see they're working on a city district and pushing that towards biogenic production. And here then it is done with experts, they're representatives of organizations, so it becomes a kind of commissioned project. And we're going to do this also, but our aim is also to do this with children. This was in a the Art and Architecture Biennale in Chengdu, where we created a very complex smart city project for the city, but actually in the exhibition we had children and their parents playing games. They didn't really know what was going on, but they played the game and they knew something could be done by them. So it's a kind of participatory process that I'm very kind of happy with that we did that. And we will do more of that. The reality is, of course, sorry for the fuzziness, that we also have to understand the city in all systems and the kind of data representation of these cities. What we normally call city is this part here, right? But the communities, logistics and data are actually the layers making up a city. So the last bit is how do we create circularity? I will not stay very long, but for circularity we need these kind of diagrams of what material flows go where. We have to create taxonomies of materials and these cascading things, so we can kind of grasp the reuse of materials. And we created a simpler one for the use of bamboo and eventually the construction and the mix of bamboo with other materials to create a kind of hybrid thing and to look then how to digitize all of that. You have to do that before you even start with working on a kind of new material value chain. So the last few images I show is of this model we're working on. It's called technically a value chain digital model. More popularly, we talk about biogenic city maker incubator, and it's based on this diagram that we're developing for the Bauhütte, that we're saying, okay, we may want to plan with forestry here and go from wood to a city, but the reality is like that. This is a kind of production process, and in between are digital connections. So here you see a few glimpses of the tool in the laboratory we have now, where you can go the full range from the forest via building kits towards circularity. So now we're in a new interpretation of this value chain. And here you see a few glimpses of the dashboard of it, where this is the total value chain, and here you kind of move around the forest. It's all interactive. So we take delegations and we kind of take them through the whole chain. So for example, here we have the forest. So we are able, I cannot show you really how it moves, right? It's all interactive, but we can move around. We can almost reach every tree here in the forest. And then these numbers change according to where we move around, landowners here. And then we go into architecture where we look at kind of particular kind of apartments in a piece of city. What are the components made? Where are they? How many of them? Always coming to numbers. You know, how much of the carbon balance, how many units themselves. And this is an existing project. It's a wooden project just built by an architect, one of our partners in Berlin. And we've been analyzing that as part of a series of different pathways, different typologies of wood buildings. And here you see the numbers again, carbon, but also volume. And this relates to that new city district in Berlin. And this district, right? And this is maybe the most important one, because now we go into kind of city scale. This is still small, 6,000 housing units. But these numbers are very important, because by the use of sliders here, the choosing of different pathways, different logistics, we know exactly, the energy use, we know carbon balance, and these are the things that legally become required now in Germany. So these are the legal kind of guidelines, not guidelines, they're laws coming into effect now that every investor has to look at. So this is becoming a kind of tool for investors and planners and so on to kind of measure the impact and to see they're legally kind of fitting the laws. And now that's the end, really. But what I wanted to tell you is that planning is also moving, and architecture is moving into a new phase, which is extremely exciting. But you have to also look at a very broad spectrum of technologies, participatory processes, and so on to do building by nature. It's not a simple thing, but it's also a beautiful thing. It's amazing, and I think we got to do it. This is the new architecture. A lot of this stuff will be published. So we're actually working on a set of books done by Yapsam publishers. Here you see the covers of some of them, some older projects. This stuff I showed you, the spheres, will become part of a book called Climate Crisis, Planetary Mapping. There's some other books that's partly our older books, and they will look like that or change. I don't know yet. So this is part of the focus. The other focus is becoming active with this new institute, the Bauhütte 4.0, to push the process of bio-based building very hard and turn it into a global trend. And I hope to work with you. I hope you're going to pick up a lot of this. Maybe you're already doing a lot of this. And I'd like to stimulate that, and maybe I see some of you in the workshop. So thank you. So I was told there may be some questions.
Yeah. First, I thank you for the lecture. I believe that all of the audience gained a new perspective of what building the nature means. And I would like to ask if there's any question from the audience.
Don't be shy. Think of ice. Somebody has to break the ice. Yes, please, Chris. Sorry, you have to speak up because it's kind of noisy here.
When the program is doing the modeling for the reduction or increase of carbon, you factor in transportation
Yes.
and distance.
Yes, we are. This is a good question because at the moment, if I go back quickly to answer that question. So, the colored bits here are normed bits that are legally normed now, right? They are part of ISO norms and things. Well, what is in between is transport. These things are normed by themselves, but not as part of the value chain for architecture, for wood production. So this looks nice and complete. It's not at all. In reality, it's completely fragmented. For example, also, we just 2 weeks ago, we made a breakthrough that we can link GIS data to BIM modeling, right? You probably know BIM modeling, right? Used by architects now. This didn't exist before. So we have made this breakthrough. In this tool, we can now move from satellite data for forestry to BIM modeling of architects to city planning model. This is completely new. Nobody has this in, at least not in Europe. So, secondly, these horizontal layers, they're all influencing this value chain. None of them are really connected today in a kind of factual way. So to go to digitization, for example, we don't really have a continuity there yet. Or we don't know the impact of creating a digital model, right? We're going to work on digital twins right now. We'd have to, but we don't know yet quite how they will impact it. Your question to transport, yes. In the tool, we have sliders that say if you go from, I think it's here. Where is it? Here. Yes. So we have. I don't know by heart the tool, but we have sliders where you can shift from diesel trucks to autonomous electrical trucks to ships, electrical ships. Right. The TU is building electrical ships now. We have to work with those. Then these numbers change radically. But architects usually don't have influence in the way that wood is being constructed. They usually don't know where the wood is coming from, even. So these, yes. So we cover everything, but it is a prototype. We have a small team, not much funding because it's quite cutting edge, and it needs a few million to get the developers behind it. The software is very simple still. So it's a prototype of a tool that once, if it would really properly be functioning, but I say properly function, it cannot actually, because there's still too many gaps between some of these things. So it is more in order to create comparative values and let people imagine what it is they're actually working with. And so we have now a lot of delegations, and it becomes a kind of didactic tool, more than exact science, I would say, which is I'm glad with, because it means yes, please. Any others?
I'm not sure if I can follow you all, because there's a lot of information. Sorry.
Yes.
But can you go back to the narratives before?
Which one?
No, before this, I'm the one who asked the A1 process diagram, the A1.
This one.
This one.
Yeah.
A1 still use right now the construction that we do in Germany is using the wood in German, right?
Yes.
Okay.
Yes.
And you recommend us to use bamboo as package
Yes.
for Asia?
Yes.
We have more of bamboo here.
Yes.
Do you think so the function of bamboo is available for laminated things like that?
Yes.
For
Yes.
for the industry, wood industry?
Yes. This is a kind of difficult question because, of course, the majority of wood, like this wood here, is laminated, right?
Yes.
These are CLT panels. So when you go to Sweden, right, you'll see a lot of these made by Stora Enso, for example, right, a big company in Sweden that makes it. There are many problems here, right? Problems for fire and all that, but some things that the industry has not yet mastered is the problem of glue, for example, right? You go to some of these factories, like I showed you, these are gigantic, and 10% of that's glue. And there are no green or organic glues in the world yet. So this material is technically not recyclable, actually. So there are many things that are not solved, also in the wood industry, right? Bamboo even more, because when we looked at the earlier value chain diagram that Vasita made, but the bamboo forestry is still the question of how do you harvest, right? Transport is the same problem. But bamboo is highly fiber-based once you take it apart, and so the biggest thing will be, can you create? I have bamboo blocks on my table, right? But some are made with glue, laminated. Some are completely fiber-based. That means they're shredded. Some are heat pressed. Means no glue whatsoever. I have a few blocks from China, from a factory I visited. If we would master the energy generation, that we can do that, that's ideal, because the sugars in bamboo are the bonding. They're perfect. But energy is high. Glues are not yet there, so with bamboo we're still at the beginning. We're at the beginning, really. Of course we have some flooring and some decorative use, and IKEA makes some things, but it's really at the beginning, and it's still big, so it's not yet, like in wood, it's more or less viable. Bamboo not yet, but I think it's the future. So
your assumptions is that coming more things would be strengthened the bamboo qualities.
yes, well, if you look at the kind of numbers of times of growth, right? You talked about teak before, and we're looking at the forest. People always ask, is there enough bamboo to build everything new in Germany with wood? Yes, there is. That district, we have now, because we work with experts, right? Experts in other institutions, right? I don't know these things, but they know. So, for example, the wood you would need for that big district grows in about 2 days in the state of Brandenburg. That's the reality. So there's more than enough wood in the world to build with wood, but it also takes time, and there's issues. There's loss of natural environments, like you mentioned, the teak, right? It's not anymore, it's kind of done. In Germany, also many forests have to be recreated, right? In Indonesia, you have to start beginning to this restoration process, and there's a lot of debate. Are you allowed to do that, and how do you create this restoration? How do you link it to conservation and things like that, and biodiversity? So it's complex. And if you look at other materials like mycelium, so mushrooms or bamboo, they have the advantage of being fast, right? Like with bamboo, a good plantation, you have for the harvest. If bamboo is not wood, right? It's a grass, but you have a harvest every four times a year. It's one of the possibilities. It's not the holy grail, it's not the only thing, but it's one of the ways that we can be faster. Yes, I think so. Yeah. And one of the things, we're now looking at, I was looking actually for an image, we're drawing now maps of all the countries in the world where bamboo is growing, because I'm also fascinated by that on a global scale, and we're creating a global bamboo belt union. Maybe some of you want to be a member of that. You have to talk to Vasita, she leads that. And so mostly filled with ex-students all over the world, and it's quite exciting because it's very light-footed at the moment, not industry-driven. Just us and ex-students, and just to see who's doing what, where you have experiments, because there's so many species, production methods, we don't know yet. Any other questions? Come on, you guys shouldn't be shy. No time to be shy. Anything. Anything you want? Yeah, please. Maybe you have to. Very hard to.
I'm kind of interested in the diagram that the concrete was built and you include the bamboo or the wood structure. Can you do that?
Ooh, which one was that? Which one? Is it backward?
Almost, yeah, backward. Almost. Like red and blue diagram.
Okay, I'll just go back. You say when, because I'm not sure which one. So we're going to go through the lecture backwards. It's interesting. Nice to see you. Much more backwards, probably, right? Maybe.
Oh,
Here?
Yeah, I was interested, like, do you think how long or do you think it has potential to like develop the city in Berlin or in like other countries to like mix with the wood or bamboo structure or architecture with the steel or concrete?
Yeah, okay.
I think it has potential.
Yeah, I have some not here. I have some diagrams about the comparison between concrete. Concrete, we need, the future is hybrid, right? We need always concrete for some things. Like, you know, in Europe, they're beginning to build bridges out of solid wood. I mean, but it's a slow process, right? But so we will still have cellars, basements in concrete, although we shouldn't, right? This process is slow, but we need to speed it up also. This is a test about Nachverdichtung in German. That means densification of an existing city, right? And it's a test that is actually very important right now because in Germany there's lots of discussion about extending what here is a bomb site from the last war, about extending the buildings out. Can this be made of wood? Can this whole set of blocks be made in wood? And that's what the government will. Can all these buildings that were built after the war here like this, they're industrially made buildings, can they be given 2 more floors with wood? So because wood is lighter than concrete, it's useful. Right now we're looking at a big grant that will help us to support the creation of this in wood. You see here's an example, here's an example. So this is a vision from us, but the actual discussions are going this direction. Now even this would be very interesting actually, kind of an extension sideways. I'm sure you do some exercise like this. Now at the moment we're starting a process where it's not all necessarily in wood. We're actually beginning to look at an extension of the tool where we're able to select, for example, maybe wood is not available on a certain amount of weeks or days, but there's a big movement of recycled concrete. So maybe we'll have buildings that have a mixed, that one part is built with recycled concrete, one part is based with green concrete, one part is based on wood, one part is based on some experimental materials. We are going, in the next few months, we're moving in that direction. It's more mixed and also interesting for architects. Yeah? See, that's a nice question actually. Because it shows stuff that is just happening now. I'm sure more will come later. Chris, or one, yeah?
I think it's really exciting when we're talking about this in Southeast Asia. Massive consumer is starting to pick up, but it's a very hard conversation. We have to bring in the products from Germany or Finland, things like that, so the cost is very high. How do you think we can ask our clients and developers to go this route when costs are a premium for them? Is there a way that we can tie in carbon credits or value chain extra costs and benefits through the carbon exchange incentives that we can say, okay, this is going to cost you 30% more in construction of the concrete building, but you will get X amount of value carbon credits.
Yes.
And then they bank that incentives.
Yes.
That part of the
Yes, I mean, first of all, that's about the question of innovative finance. This is actually the key, right? It's very boring for us architects, but actually innovation in finance and regulations is the key, but it will cost a breakthrough, of course, apart from politics and people's interests. But we did a study for Tegel, right, which was is the project developer for this district. And one of the things we worked on is at what point, the first few years in the district, the housing would cost more, but 10%. Partly because the prices of wood are higher. That has now changed. Now the price has come to lower, but it's still 10% more to build in wood. And then the question is why, right? And so there's several answers. One of the answers is, of course, in Europe now there's something happening. It's called the taxonomy. It's a new economic framework in which there are going to be regulations that say you as a company, if you run your company, including investment, or you run a hotel, or you create housing, you have to meet these standards. And the standards are going to be about, for example, CO2 emissions. Not only, there are many, but they deal with a kind of green plan that Europe has. And companies have to be ready for that, because in 5 years or something like that, this kicks in. And if you're not ready for it, you may die as a company. These are pretty hard rules. So that's one thing. So they have companies, investors, and so we'll have to get ready for these things. And we have 3 banks on board now of this new institute, and they all know this, and they're super smart. They're already planning where their investments will go. Because in Germany, pretty soon there's going to be a carbon tax, and the higher the carbon tax goes, the more problematic building with a lot of carbon emissions goes. But the same is for logistics and everything. So the second thing is that if we begin to look at the overall value chain, right, you can begin to gain, as it were, in this kind of in these things of carbon reduction, but also waste reduction, circularity. You have a lot of gains. And in a tool like this, you can begin to measure and accumulate all these gains together. It's a complex thing, right? But bit by bit, the whole formula changes. You may gain a lot by having a kind of sustainable logistics, which is then supported, right? And so the complexity gives you a chance to begin to look at an economic picture that bit by bit changes the balance, where it becomes maybe more sustainable, financially sustainable to build this than with quick steel or quick concrete, without the regulations and the taxing. And then the core aspect that we are developing together with Fraunhofer is intelligent production. So our argument jointly is with the intelligence of new tools, with new production, we can lower the price of construction through mass production. This is very controversial. A lot of people are scared, right? Oh my God, we want to build a beautiful building, and if you big mass production. But I'll give you one example. Indonesia the current government has a program of creating 1 million affordable housing units each year. Go to Indonesia, talk to the authorities and people. It's not happening. It's happening kind of bit by bit, like a collage, but not affordable, not sustainable, and so on and so forth. So this is one of the arguments I'm working in. In Germany, it's the same. The government wants to create 400,000 housing units each year, or make sure that happens. 100,000 from those are supposed to be affordable. And, of course, sustainable. Nobody can do that. There's no industry, no planner, so they're not meeting the target. So it means that leads to inner conflict in the government, because the government has set climate targets. So we're reaching the point where there will be a lot of conflicts inside the governance structures. And so what we are working with, and this is really funny, because I had to grow into this the last few years, right? By studying these logistics and the Chinese project being 50 times in China and so on and so forth. I have to understand it's not a bad thing to link design to production, to link city growth to natural growth. This is the kind of mission we have now. And so I believe that intelligent production is actually a necessary method. But the intelligence also gives rise to new creation, new innovation, and architects can really use it as an innovative tool. And that, I don't mean parametrics, making some funny curved buildings, right? But really being intelligent in the way of designing, because. And then you can say what we are talking about is agile factories that can create basically custom-built components that are cheaper, more economic to produce, and that's the only solution. So you can create many components to reach these targets of 100 or 100,000 or a million units, but with lots of agility and lots of creativity. But the problem is architects. Architects at the moment are not connected yet to the other parts of the value chain. Now, I was in a meeting of the BDA, that's the Association of German Architects, the main national association. Because I'm now elected as a member finally, although I don't build houses. So I was shocked. They're nice people. They all built in wood. They are so nice. Now this is recorded, so I'm not going to say what my misgivings were. But sometimes there's a kind of limit that we teach architects, or that the architects are operating in the kind of territory. So we have to also make sure that architects are brought back, brought forward into the value chain. That they are facing, and we're doing that now in workshops, that planners, architects, and investors are facing the owners of the wood. They're sitting at the table, right? They say, I have a tree, and you're designing my tree, you're investing in it, and here's the engineer. This is the kind of work we do now in workshops. And that's fascinating because it becomes a human-to-human contact where architects learn to design, knowing the transport mode, knowing the wood, the forest where it comes from, knowing recycling afterwards. And it's actually very beautiful. And it's actually based on human contact first. So all those tools are interesting, but actually the really interesting thing is getting people in a room together. And then together you can lower these prices. We're claiming we can get 30% cheaper than concrete once our research factory is up and going. We'll see. But if we don't do this, you know the consequences. Just make your own calculations. You keep building, growing, and look at the growing cities. Maybe not so much in Thailand, but I'm now looking at the growing metropolises in Indonesia. I know what's happening. We all know what's happening. You put a calculation to that, business as usual. Calculate it's catastrophic. So we know what's going to happen. So we have to try to shift these curves. And that's the key to that is integration. Think integral. Think integrated. And for a while I was really depressed. I was working a lot also in smart cities. That in my last AA years, I started to look at these companies that push the smart city development. So I went to a lot of conferences and congresses. No architects ever there. No architects ever to any of those conferences. So for a while I thought, whoa, this is the new world, right? Driven by engineers. You get a kind of star architect like Big, right? To build the Google headquarters in London. Amazing, right? You think Google would be the first one place they have the money, right, to make the most extreme. So what they do, they hire a star architect, Big. Look at the building, huge steel construction. It has some sort of bicycle pathways, and then they're rendering some green hanging from it. But that's not a kind of radical breakthrough. So that's what's happening. That's the role of architects. They get big to do these kinds of things. That depressed me. I thought, well, then that's it. The end of the profession, right? But then I grew again optimistic, and now I feel the architects are at the center of everything because they are like cultural ambassadors. You represent people and society. That means architects have to somehow design the whole process. But I discovered that nobody in the world is designing this thing called this value chain. But I showed you that there are no people in charge of this. There's no profession, no discipline, and a lot of things we think is boring, but it's not boring. So I feel now the architects are at the center of this creative process, and they have to lead. So I'm very happy that there's a next generation, people like Vasita and other students, so that are interested in this, are pushing this. So, because it's not even your world, it's your children's world that is going to pay the price. So, okay. Yeah, anything?
Thank you all for the question. We reached the end of our session and we want to conclude here. And before we start, I'd like to extend our gratitude to Professor Bunschoten for his time and expertise in this
Thank you. Thank you all to those that were online. But yeah. So. Thank you. Thank you. So, very good. Thank you.
Thank you everyone for your time, and this is the end of our session, and hope to see you all in our next lecture that will keep happening soon. Thank you.
Thank you.